Hello children, how are you all? I welcome you all for the second session of the chapter circles. In the previous class, I have given two activities. So, the activity 1 is like this: construct circles of different radii and mark any point on the circle, draw a tangent at that point, draw radius at the point of contact and measure the angle formed by the radius with the tangent. What is your inference? I think all of you have done this activity and you are eagerly waiting with your inference. Let us watch what is your inference in this video. Yes, we have marked a point P on the circumference of the circle and we have drawn tangent XY, and OP is the radius drawn at the point of contact P, and the angle formed with the radius and the tangent is 90 degree. It is right angle. Yes. So, even though if I increase the radius, you can observe that the angle formed is 90 degree only. Now, I am changing the position at different points. You may put the point in anywhere on the circumference, at any point on the circumference. When the tangent is drawn at that point and we draw a radius at the point of contact, the angle between the radius and the tangent is 90 degree, or otherwise we can say tangent drawn on any point to the circle is perpendicular to the radius drawn at point of contact. This is what your inference for the first activity. And I have given one more activity, that is draw 3 circles, mark a point inside the first circle, mark a point on the second circle and mark a point outside the third circle. Now, draw tangent to the circles. From these points, find the number of tangents that can be drawn. What is your conclusion? So, for these 3 circles at different points, how many number of tangents can be drawn? We will discuss as result 1, result 2, result 3. First, let us discuss the result 1. When the point is marked inside the circle, you have tried to draw the tangents to the circle by placing a point inside the circle, but you find that it is not possible to draw tangent to a circle from the point inside the circle. Yes, we cannot draw. Next context is, I told you to mark a point on the circle. In the second case, we are marking the point on the circle. Now, the point P is inside the circle. Now, we are taking that point P on the circle. Observe how many tangents can be drawn. You observe only the line which is in blue color is tangent to the circle and all other are secant to the circle. Yes, observe, when it is inside we cannot draw the tangent. When it is on the circumference, when the point is on the circumference or the point on the circle, the number of tangents can be drawn is only 1. Yes, your observation is correct. We can draw only 1 tangent on the circle. Yes, observe, only 1 tangent can be drawn on any point on the circle, but a circle has n number of points. So, we can draw infinite number of tangents on the circle, but on a point we can draw only 1 tangent. What is the next context we have given? That is, we have to draw tangent from the outside the circle. Inside the circle, no tangents. Yes, inside the circles we can't draw the tangent. Now, we are trying to draw tangent from the outside the circle. Observe here, when it is on the point it is 1, when it is outside. So, if you observe, if the point is anywhere, but it should be outside. So, when we put the point outside the circle, the number of tangents that can be drawn to the circle are 2 tangents. Yes, the observation we record like this. Observe here, the lines which are in red colors, only 2 tangents can be drawn from the point P. Yes, only two tangents can be drawn to the circle from an external point. Then what is the length of the tangent? When we draw the tangent from the external point, what is the length of that tangent? How to measure the length? Here B is the point from where we are drawing the tangent, and C and D are the contact or points of contact to the circle. The length between B and C are the length of the line segment BC, and BD is the length of tangents. So, BC and BD line segment are the lengths of tangents drawn from B to the circle. Let us recall one concept to understand the properties of tangents to the circle. What is that concept? We have studied this concept in the 9th standard. Observe in this figure, I am drawing a line from C to the straight line AB. If you observe, that line I have drawn is making angle with the straight line AB. If you go on observing all the examples and the length of the line, you observe that the line which has 4 units length is making an angle 90 degree, or is making right angle, is the shortest length to this straight line AB. Then what is the conclusion? The shortest distance drawn to a line from a point which is not on it is its perpendicular distance. In the same way, we will observe this shortest distance in the circle. Okay, observe, O is the center of the circle, P is the point on the circumference of the circle. Now I am drawing a line y1 y through P. OP is the radius. Observe, OQ is one more line on the straight line, but if you observe, the radius that drawn at the point of contact to the tangent y1 y is the shortest distance. Since it is the shortest distance, it is making an angle 90 degree. We can say tangent drawn on any point to the circle is perpendicular to the radius drawn at point of contact. By this, we can conclude that the angle between the radius and the tangent is 90 degree. Okay. Let us prove this by logically. This statement we are going to prove, and this is called as the theorem 4.1. Examination point of view, the 4.1 theorem is very important. In this chapter, you will come across two theorems, 4.1 and 4.2. For the examination point of view, we expect either any one of the theorem for the 3 marks. 99.99% they give this theorem for the examination. So, the statement of the theorem is like this: tangent drawn on any point to the circle is perpendicular to the radius drawn at point of contact. How to prove this? First, let us draw a figure with the help of the data. O is the circle. We name the circle with its center. Yes, O is the circle and P is the point of contact between the tangent xy and circle. OP is the radius drawn at the point of contact. This is the data given, and we have written the data in sentence also. O is the center of the circle, the line xy is the tangent drawn to the circle at point of P, OP is the radius drawn at point of P. In order to prove OP is perpendicular to xy, we have to show that OP is the shortest distance to xy. To show that, let us do some construction. What construction we are doing? We are marking point Q on tangent xy other than P. So, other than P, we are marking point Q and join the points O and Q, the center and the Q. You can observe OQ is intersecting the circle at point R. Yes. Let us prove this by step with reasoning. Q is the point on tangent xy other than point of contact P. That we will write. Q intersect xy at R. Now observe OR is less than OQ. Yes, because it is intersecting circle at R. By observation only we can see OR is less than OQ. But OR and OP are one and the same. Why? What is the reason? Yes, radii of the same circle. You can observe the statements 1 and 2. By observing statement 1 and 2, we can draw conclusion that OP is less than OQ. Hence, we can conclude that OP is shorter than any line that joins O and any point on xy other than P. Now, OP becomes the shortest distance for xy, hence OP is perpendicular to xy. We have quoted the reason. The shortest distance between a point and a line is its perpendicular distance. Hence, we proved this theorem. This theorem is very important for the examination purpose. Children, practice this. Okay. Now, let us solve some problems that we have given in the session first. I told you to answer the exercise 4.1. In 4.1, we have first question like this: number of tangents that a circle has. So, on any point on the circle, we can draw only one tangent, but on a circumference, we can put n number of points. At each point, we can draw a tangent. Hence, the answer is S. You are right. It is infinite number of tangents that a circle has. Next question is like this: a tangent to a circle intersect it in dash point. Meaning of tangent is what? Touches the circle. Touches the circle means it meets the circle at only one point. Correct. The answer is only one point. What is the next question? A line intersecting a circle in 2 points is called. So, we know if a line intersects the circle at 2 different points, then it is called as secant to the circle. Next question was: a circle can have dash parallel tangents at the most. So, this we watched a video regarding this. How many parallel tangents a circle has? Only 2 parallel tangents a circle can have. The common point of a tangent to a circle and the circle is called. What we call the point that the tangent touches the circle is called as? Yes, you are right. It is point of contact. And one more question. The third question in exercise 4.1. A tangent PQ at a point P of a circle of radius 5 centimeter meets a line through the center O at a point Q, so that OQ equals 12 centimeter. Length PQ is. Let us draw figure for this one. The options they have given like this: 12 centimeter, 13 centimeter, 8.5 centimeter and root 119 centimeter. For this, let us draw figure first. OP length they have given, it is 5 centimeter and OQ is 12. We know that radius at the point of contact to the tangent is perpendicular. It makes an angle 90 degree. Apply the concept that you have learnt in the chapter triangles, that is Pythagoras Theorem. Here the hypotenuse is OQ, but we need the length of PQ. Hence, PQ can be written as hypotenuse square minus OP square. Yes, hypotenuse square is 12 square and OP square is 5 square. On simplification, we get PQ square equals 119, but we need the length of PQ. So, taking square root on either side, we get PQ equals 119 centimeter. Option D is the correct answer. One more question. The fourth question is like this: draw a circle and two lines parallel to a given line such that one is a tangent and the other a secant to the circle. So, I have shown you how to draw with the help of video. O is the circle, AB is the line outside the circle. Now, at point C, we are drawing a parallel line to AB which is a tangent to the circle O. Now, we are drawing one more parallel line through E and D. That line intersect the circle O at E and D. That is the secant to the circle. We have answered the question 4. Next question, prove that in two concentric circles, the chord of the larger circle which touches the smaller circle is bisected at the point of contact. So, here we have to recall what are concentric circles. We know having same center with different radii, we call those as concentric circles. Watch this video. O is the center of the circle, we have pink color circle with center O and we have grey color circle with center O. Yes, both are concentric circle. On the smaller circle we marked point P. Through P we are drawing a chord AB to the larger circle. Now we have to prove that OP bisects the AB. Yes, it is bisecting. You can observe the length is not changing. AP equals 4 and PB is equals to 4. This we have to prove logically. How to prove? This is the example 1 question in page number 100. Okay. So, this is the statement given. Now, we are going to draw the figure according to the data given. Here C2 is the smaller circle and C1 is the larger circle, P is the point on the smaller circle and AB is the chord to the larger circle that touches the smaller circle at point P. We have to prove that OP divides AB such that AP equals PB. So, that we are writing as data. C1 and C2 are concentric circle with center O. AB is the chord drawn in C1 circle such that it will be tangent to the circle C2 and touches the point at P. What we have to prove? That we are going to write now. To be proved, AP equals to PB. When OP bisects AB, then only AP equals PB. Yes? Okay. So, for this we need to do some construction. We have to join O and P. I have already joined that O and P. Proof. AB is the tangent drawn to the circle C2 at point P and OP is the radius. Now, we know through theorem 4.1, recall theorem 4.1, what does it says? The radius drawn to the tangent at the point of contact is perpendicular to the tangent, or tangent is perpendicular to the radius that is drawn at the point of contact. That means both makes an angle 90 degree. Okay. And we have also learnt that OP, if OP is the perpendicular line, then this becomes the shortest distance for AB and this perpendicular line divides the chord into two equal line segments. That we have learnt in the previous class itself. OP divides the line AB into two equal halves. Therefore, AP equals PB. The reason is the perpendicular line drawn from center to the chord bisects the chord. Hence, we proved AP equals PB. Let us solve one question related to this concept only. It is there in your exercise as exercise problem 7, page number 103. The problem is as follows. Two concentric circles are of radii 5 centimeter and 3 centimeter. Concentric circle means larger circle as 5 centimeter radius and smaller circle as 3 centimeter radius. find the length of the chord of the larger circle which touches the smaller circle. We have to find the length of the chord of the larger circle, that is the tangent to the smaller circle. Let us draw the figure first. Now observe, C2 is the smaller circle with radius 3, C1 is the larger circle with radius 5, OP is the radius at point of contact P. We have to find the length of AB. Observe OPB, if we join O and B, OPB is the right angle triangle. So, applying Pythagoras theorem here, since OP is perpendicular to AB, this OPB is a right triangle. Applying Pythagoras theorem, OB is the hypotenuse because it is opposite to right angle. So, according to that, OB square equals OP square plus PB square. OP is the radius of the smaller circle, OB is the radius of the larger circle. We need to find PB. Hence, rearranging the statement, PB square equals OB square minus OP square. That means PB square equals 5 square minus 3 square. On simplification, PB square equals 25 minus 9, which gives PB square equals 16. Taking square root on both the sides, we have PB equals plus or minus 4. Since it is length, we take only positive root of 16, that is PB equals 4 centimeter. We know PB, we have to find AB. Since PB equals AP, AB equals AP plus PB, that is 4 plus 4, which is equal to 8 centimeter. The length of AB is 8 centimeter, children. This how we solve this problem. Okay. Now, I will stop this session here. I am giving you an activity. The inference of that activity is the beginning of my next class. What is that activity? Observe. Draw circles with different radii and construct tangent to the circle from an external point. Then find. You have to draw 2-3 circles with different radii. For each circle, mark an external point, and from the external point, you have to draw tangents. You know how many tangents can be drawn from an external point? Only 2. Yes. Then you have to find the length of those tangents. Join the center and the external point through a line segment and find the angle of inclination of tangent with this line segment. How much the tangent is inclined to the line joining the center and the external point? You have to measure. What is your inference? Record your inference. We will discuss that in the next class. To do this activity, you need to know how to construct tangent to a circle from the external point. That I am going to explain now through a video. Watch the video and learn. It is very easy. You will learn this in the chapter construction, but as if we need to construct the tangent to the circle, it is very simple. I am going to teach you now through a video. Observe the video and learn how to construct the tangent to a circle from the external point, children. Then you do the activity that I have given. Okay. We are going to learn how to construct tangents from an external point P to a circle. For this, we are taking one example. Construct two tangents to a circle of radius 3 centimeter, which is 6 centimeter away from its center. So, first step is, we know the distance between the center and the point is 6 centimeter. Hence, we are drawing a line segment of 6 centimeter with the help of scale and pencil. O is the center of the circle and P is the external point, which is 6 centimeter away from the center. Now, we know the radius of the circle is 3 centimeter. So, we are taking 3 centimeter radius in the pair of compasses. With center as O, we are drawing a circle of radius 3 centimeter. Now, we are going to draw perpendicular bisector by taking the measurement of 3/4 of line segment OP. With center O, we have drawn two arcs. Now we are intersecting the arcs drawn with the center O from the point P without changing the radius. X and Y are the intersecting points. Now join X and Y. Now XY line segment is the perpendicular bisector of OP. Now with the radius OA or AP, because both are same, with center A, draw a circle. Now the second circle C2 cuts the first circle at Q and R. Now join PQ and PR. You can observe PQ and PR are the tangents drawn to the circle O from the external point P. Now with the help of scale and divider, measure the length of PQ and PR and draw your inference. I think you have watched the video. You will do the activity with your inference. You wait for me for the next session. Let us recall what we have learned in this session. First, we have learned the concept tangent drawn at any point to the circle is perpendicular to the radius drawn at point of contact. One more concept that we have learnt in this chapter is we cannot draw tangent to a circle from the point inside the circle, whereas on the circle we can draw only one tangent. Then from the external point we can draw how many tangents? Yes, we can draw two tangents from the external point. And one more thing we have learnt is theorem 4.1. The statement of the theorem is like this: tangent drawn any point to the circle is perpendicular to the radius drawn at point of contact. This we have proved logically. What you are going to learn in the next session? You are going to learn one more important theorem, that is theorem 4.2 and problem related on it. Okay, I think you will all do the activity and you will all draw the inference and also try the exercise 4.2, which is in page number 102. Try to answer the problems 4, 5 and 6. So with all your answers and with all your inference, wait until for the next session. Until then, thank you children. I am Sucheta SS, mathematics teacher, T. Dasaralli, Bengaluru North 4. Thank you.